In this video, I'm going to show some more examples with different type of functions to find out the Laplace transform. Okay, let me take example 1 is find the Laplace transform of the function ft where f of t equals to e to the at. So exponential function with a coefficient a where a is a real number. Okay, so how do I find out this? Is to find out the Laplace transform of the exponential function with a coefficient a in the exponent. So how do I do that? Let's use the definition of the Laplace transform. So Laplace transform of f of t. So the Laplace transform of f t is 0 to infinity e to the negative st times f of t dt, where s is positive, right? So how do I do that? Is let's plug in that value. So 0 to infinity and then 0 to infinity and then e to the negative st times ft is e to the at, right? And then dt. So this can be written as this way, right? Let me write down that infinity in the limit form. Limit beta tends to infinity 0 to beta, right? And then you can write e to the negative and then s minus a t dt, right? So what is the integral of that? So you can write limit beta tends to infinity and then the integral of e to the some number times t will be e to the negative s minus a times t over negative s minus a. You see that? And what are the limits? 0 to beta, where beta tends to infinity. Now plug in beta. Limit beta tends to infinity. Let me write down that negative sign outside and then use the just plug in those limits. So you can write e to the negative s minus a times beta over s minus a, because I took that negative sign outside, and then minus e to the minus s minus a times 0 over s minus a. So what you get is limit beta tends to infinity, negative sign, right? So since this is negative, since this value is negative, then what do we get? We get, suppose that this value is positive, that is s is greater than a. Suppose that s is greater than a, then s minus a is positive, right? So this positive means, and then beta is tends to infinity, right? So this exponent is basically negative. So I want to move that and then I want to write like this: s minus a e to the s minus a times beta, right? And then minus, how much is that? E to the 0 times that is just 0. So that will be 1 over s minus a. Okay, what are we assuming here is we are assuming that s minus a is positive. If s minus a is positive, then this exponent will be negative because there is a negative s minus a times b. So I move that to the denominator to make it positive. Now let's take the infinity for beta. So this will be 1 over a very big quantity, right? So this will go to 0. You see that? So basically what happens is this goes to 0 and there is a negative sign. So that is basically the positive sign, right? So you will get basically this is equals to positive 1 over s minus a, where s minus a is greater than 0 or s is greater than a. Okay, this is what we get for this one. We do one more example on this. Let's do this example, just direct use of this formula. We see that the Laplace transform of e to the at, where a is a real number, is 1 over s minus a, right? So what will be the Laplace transform of e to the negative 3t? So the answer is 1 over s minus the a is negative 3, right? So s minus the negative 3, that will be 1 over s plus 3, okay? So before I go to the next example, let me ask you this. What is the integral? How do you find the integral of e to the iat? If it was just e to the at, right, without I, then we can just use the formula e to the at over a, right? But if there is iat, how do you find the integral? What we do is we use the Euler's formula, right? What is the Euler's formula? The e to the iat can be written as cosine at plus sine at, and then there is I also. So I sine at and then dt, right? Dt, that's what you get, right? So what you do, you find out the integral of that. If you find the integral, then it will become 1 over a, right? 1 over a sine at, and then minus I over a, and then cosine at. So this can be written as, let me take the 1 over a out, right? What happens there is, I want to write negative I cosine at, okay, and then plus sine at. I have to use the Euler's formula again. So what is the Euler's formula? Euler's formula is e to the iat equals to cosine at plus I sine at. I want to use that formula again here, but what I want to do is I want to divide and multiply by I. What do I get? If I divide and multiply by I, so if I divide and multiply by I will get 1 over ai, right? And then here, if you will have to multiply by I, right? So negative I square, and then cosine at plus I, and then sine at. I'm multiplying and divide both sides, I mean the top and bottom, by I. So 1 over ai, right? So what do you get there is negative I square is 1, right? So cosine at plus I sine at. You see that? So how much is that? 1 over ai, right? And then this is e to the iat. Basically the rule that, you know, that we were talking about, the rule that e to the at dt is e to the at over a. Similarly, what we got here, exactly the same way, what we got is, if you have e to the iat and then dt, right, the integral will be e to the iat over ia, right? So you can use this formula. So it is similar, it works the same way. That's what I wanted to show you, okay? That by the similar method, by similar techniques, you can show that e to the a plus ib equals to dt, okay? E to the a plus ib t dt equals to e to the a plus ib and t over a plus ib, okay? We can use exactly the same method to prove this, okay? So now what I want to do next is, so as the integral of e to the iat is e to the iat over ia, so it follows the same integration pattern as e to the at, right? Similarly, the Laplace transform of e to the iat will be 1 over s minus ia. Do you remember that? What was the Laplace transform of e to the at? It was s minus a, right? But when there is I, it will be s minus ia, okay, where s is positive, not greater than a, where s is positive. So the same techniques can be used to find out the Laplace transform of the Laplace transform of e to the a plus ib and then t, right, times t. So that will be 1 over s minus a minus ib, where s must be greater than a. So I will show you how to find out the Laplace transform of sine at, okay? So to find out the Laplace transform of sine at, we will use this formula, okay? we know sine AT, right, is equals to e to the I. Let me write in the exponent. So it should be e to the IAT, e to the IAT, and then minus e to the negative IAT divided by 2I. That's what the formula for sine AT in terms of the exponential function, okay? So, but what is the integral of e to the IAT? Also, we know that e to the IAT, the Laplace transform of that, right, equals to 1 over s minus IA. And then Laplace transform of e to the negative IAT, the same technique is, you can write 1 over s plus IA, okay? Now you combine that, because you see that if you take 2I out, therefore the Laplace transform of sine AT is equals to, you can write, you will see the linearity of the Laplace transform, you can pull that out, and then you can do Laplace transform of e to the IAT, okay? And then let me write the bracket there. Let me distinguish between the Laplace transform and the curly braces, okay? So let me write that. So it is Laplace transform of e to the IAT, and then minus Laplace transform of e to the negative IAT. You see that? So since the constant 2I, I pull that out, okay? So 1 over 2I, what is that value? So this value is 1 over, you see that, 1 over s minus IA, and then minus 1 over s plus IA, right? Now you combine those two fractions. How do you do that? 1 over 2I, and then there is s minus IA times s plus IA. So it will be s squared minus IA squared, right? And what you get in the numerator is s plus IA, and then minus s plus IA. You see why? Because this s minus IA multiplied to s minus IA become s minus IA, but there is a negative sign, so you should distribute that. You'll get negative s plus IA. See that? And then you cancel s and s. So what do you get there? Is 1 over 2I, right? And then there is IA plus IA will be twice IA over s squared plus a squared. How do I get the plus? It is IA times IA, right? You will get I squared a squared. But what is the value of I squared? I squared is the imaginary unit, right? So I squared is negative 1. So negative 1 times negative is positive 1, and then a squared only. Now you cancel 2 with the 2, and then I with the I, right? So basically you get a over s squared plus a squared. That's what you get. All right. Let me write down another example. You will do exactly the same way. Okay. So if you do that, then the Laplace transform of cosine AT. So if you do exactly the same technique, you will get basically s over s squared plus a squared. But what is the let me write down the note for it. Note that cosine of AT can be written as e to the let me write in the exponent. So basically e to the IAT IAT plus e to the negative IAT over 2, not 2I, okay? In the sign there is minus in the middle, and there was 2I in the denominator, right? And for the cosine, the formula in terms of the exponential function is e to the IAT plus e to the negative IAT divided by 2. And if you find out the Laplace transform of them separately and then do the exact same technique, this is what you will get. So this is also the formula, okay? Let me give you one more example, and then I will finish this video, okay? So let me do that example. Example is find the Laplace transform of ft for f of t equals to, let's say if there is a product t sine AT. How do you do that? Okay, this is the product. We are trying to find out the Laplace transform of the product, right? So how do I do this problem? Let me do it. So solution is, you want to find out, you want to use the definition of the Laplace transform. So Laplace transform of f of t equals to integral 0 to infinity e to the negative st and then f of t dt, right? That's what you get, right? So how do I simplify this? Is what I want to do is, so let's plug in 0 to infinity and then e to the negative st and then times t sine at, right? At dt. You see that? Now what I'm trying to do here is 0 to infinity and then t is there, e to the negative st, right? And let me plug in the values of sine at. Sine 8 is e to the negative iat and then minus e to the, e to the positive iat. Okay, e to the positive iat minus e to the negative iat, negative iat divided by 2i, right? I'm using the exactly same formula. Okay, now what I want to do is I want to pull that 2i out, so you will get 1 over 2i. You see that? And then 0 to infinity. Now I combine the, I have to distribute this to both of these and then I will combine that. Okay, so what I will get there is basically e to the negative st plus iat, right? So I'll get t times e to the negative st plus iat and then minus t to the t times e to the negative st minus iat. You see that? And then dt. This is what you get. Now what you do is you find out the you use the integration by parts for this one separately and that one separately. Okay, let me take the first integral here and then show the work for the first one. The second one you will do similarly. Okay, since you continue from there, since so 0 to infinity t times e to the negative s minus ia t. You see that? I combine that and I factor out t. You see that? And then negative t, basically negative, and then t is, I'm writing just t after the parenthesis, right? And then dt is equals to, you use the integration by parts. When you use the integration by parts, what you get is you will basically get 1 over, so you can do the exactly same technique. What we do is just do u and then dv, right? So you can take as t, right? For the dv you take e to the negative s minus ia. So if you find the derivative, it is 1. If you find the entire derivative, e to the negative s minus ia t, there is t as well, over negative s minus ia. And if you find the derivative of this, it is 0. The entire derivative of this one will become e to the negative s minus ia t over s minus ia square. You see that? Now what you do next is you multiply this positive and you multiply this one negative, right? Negative multiplication and positive multiplication. So what you get is you'll have to write in the limit form. So limit beta tends to infinity, right? And then 0 to beta. So let me write one more time like that. So t times e to the negative s minus ia and then t dt. You see that? So what you get is, just use the integration by parts there. Limit beta tends to infinity. You see that? Beta tends to infinity. And then you will get t times negative e to the negative s minus ia, right? And then t over negative s minus ia, and then minus, because this is a negative multiplication, right? 1 times that. So e to the negative s minus ia t divided by s minus ia square, right? And then outside the parenthesis the limit are 0 to beta. So if you simplify this, what you get is this will go to the bottom. So exactly the same technique, right? And then you plug in beta and 0. So limit beta tends to infinity, right? So it will be like t over, let me write a negative sign outside as in the previous example. So s minus ia and then e to the s minus ia and then t outside, right? And then plus, because I took the negative sign outside, 1 over s minus ia square times e to the s minus ia and then t. So again, you will plug in 0 and beta. Okay, guys? So what you do next is, so just plug in the beta and then 0. So so if you simplify, you will get, that will be simplified to 1 over s minus ia square. Okay, this is what you will get. Similarly, the second integral, you see that there is negative st minus iat. What I'm trying to do is I'm taking the negative sign outside. What you get is negative s plus iat, right? So if you do this exactly the same technique, your answer, you will get 1 over s plus ia square. Okay, now what you want to do is you want to combine to find out this, right? Because you want to add those two. Hence you write so integral or the Laplace transform of t times e to sine at is equals to, you write 1 over 2i, right? And then you find out you add the values of this and then that one, right? So the value of the first integral is 1 over s minus ia square. You see that? And then there is minus, and then there is 1 over this thing, right? S plus ia square. So if you simplify this, how do you simplify this? It is like s minus ia square times s plus ia square, right? Okay, so this will become, let me write out 1 over 2i, you see that? And this is 1 over s minus ia and then times s minus ia, right? And then minus 1 over this will be s plus ia times s plus ia. You see that? And then if you simplify this further, this is 1 over 2i. And then what is in the denominator? In the denominator, you multiply this with that, right? If you multiply that, if you multiply like s minus ia times s plus ia will be s square minus ia square, right? This is one. And similarly from the other pair, right? This pair, you'll get exactly the same thing. You'll get s square minus ia square, like that. You see that? Now on the top though, what you do is you just multiply the, like a cross multiplication, right? So you'll get s plus ia times s plus ia, right? And then minus s minus ia times s minus ia. You see that? Now you simplify further, 2i, 1 over 2i is there. So what do you get on the top? It is, you just FOIL this, s times s times ia, like that. If you do that, you'll get s square plus 2ia plus ia square. And then on the second one, you will get s square minus 2ia and then plus ia square. Divide by, how much is this? This is s square plus a square, right? And the other one is also s square plus a square. See that? So this is the bracket there. Now let me further simplify 1 over 2i. This is just the algebra, okay? So it is s square plus 2ia minus a square. You see that? ia times ia will be negative 1 times a square. And minus s square plus 2ia. And then this will be minus a square, but negative times minus will be positive. And then a square, right? Divide by, what I would write there is s square plus a square. There are two of them multiplied, so I am writing this s square plus a square to the whole square. Let us see what cancel out. So s square cancel out with s square, a square cancel out with a square plus minus, right? So 2ia will be 4ia. You see that? So 1 over 2I, and then I got 4ia divided by s square plus a square to the square. See that? So now what cancel out is 2 divide 4 divide 2 is 2, and then I cancel out. So basically we got 2a over s square plus a square whole square. This is what I... Okay guys.